Special guest number 3, Tabish. What do you want to say to the people?
Good luck, National 5.
It's time for Maths with Mr. Thomas.
Yes, it is. Thank you, Grace, and thank you, Tabish. Here we go with Chapter 6, Lesson number 7. Woo! In this vectors chapter, we're going to pause with vectors and take a look at 3D coordinates. Woo! Well, if you forget the 3D part, coordinates is something we've been doing for years. So you've got a coordinate diagram just like this, where you've got your x-axis just running along the bottom horizontally. Hello! And you've got your y-axis running vertically up the side here. Hello! And what you've got is you would have different points to plot. For example, the point 2, 1, where you go along 2 and you go up 1. Or 7, 4, where you go along 7 and you go up 4. Or 3, 5, you go along 3 and then up 5. So we're plotting different points on our coordinate diagram. And for each of these, well, they're just going to be in 2D. They're 2D because we've got two numbers. We've got the x value and we've got the y value. However, as it says here, often in real life, we need 3D coordinates. 2D coordinates are not going to be enough. For example, if you're wanting to find the exact position of, say, an aeroplane, let's imagine this is an aeroplane up here. And it's flying along very, very fast. If we want to find the exact position of that height, if we imagine planet Earth to be the coordinate diagram, we would have to know latitude and longitude. We would have to know how far along we are going and then how far up or down we're going, so know latitude and longitude. But what we also need to know is we need to know the height of the plane as well. We need to know how far above the surface of the Earth it is. So as it says here, if you want the exact location of an aeroplane mid-flight, you have to know the latitude and longitude, so the x and the y values, but you also have to know the height of the plane as well, and that'll give you the exact location of the aeroplane. Because of this, what happens is with our x and our y-axis, they would really just stay as they are. They are perfectly flat. We've got our x-axis and our y-axis, but we also introduce a height, and the height, instead of x or y, we then use the next letter of the alphabet, which is h. No, it's not H. It's Z! Woo! Well, so Z also gives us the height, and that is how far up from the page, up from the paper, up from the planet that we would have this plane. So when we write it down, instead of just two numbers, we now have 3. X is how far along we go, Y is how far back we would go, and Z is how far up we would be coming. Let's try a few examples. So example 1, write down the coordinates of point A. Bam, bam, bam. Just remember, for our coordinates, we have our x value, we have our y value, and we have our z value. So we're looking for 3 numbers. So if we start at the origin, which is just this big O, we need to think how far along do we go, how far back do we go, and then how far up do we go. So deal with it in order, x, y, and z. So x, first of all, how far along do we go? How far is it from here to here? 7! Yes, you can see that there, which means the x value is going to be 7. Brilliant. Now we need to think to get to this point. How far back do we have to go? We don't actually have to go back, so we're already at that point. You're perfectly right. Yes, Daniel, so that means the value would be it's just going to be 0. It would just be 0. Good, because we're not actually moving from that point. And then coming up the way, how far up do we have to go from this point here to this point here? Oh, that makes no sense, because we're already there. You are perfectly right, Lucy. Yes, you're already at that point, so we would just be coming up 0. Woo! Which means then the coordinates of point A would be 7, 0, 0. Ba 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 ba. Example 2, write down the coordinates of point B. Once again, if you think about it, you're going to have your x value, your y value, and your z value, and you would deal with them just in that order. Put brackets around them, put commas between them. So, in order to go from the origin to this point, we need to think how far along do we come in the x-axis, how far back do we go in the y-axis, and how far up would we come in the z-axis. So to go from this point to this point here with B, first of all, how far along here would we have to come? Do we have to go along there? No, we don't. We don't have to go along there. That would just be daft. It's taking us further away from the point. So the first value is just going to be 0 to show us that we don't actually move away from there. We just stay on the origin. After that, for the y-axis, how far back do we have to come? So how far do we go from there to there? How far would that be? Yeah, you can see there it is a distance of 2, which means the y value will be 2. And for the z value, well, we're already at that point, B. That's where we want to get to, so we don't actually have to move. We do not actually have to go up the way, so that would just remain as 0. You got it. Good, so we'd have 0 to 0. Example 3, write down the coordinates of point C. So for point C, again, we're going from the origin. We're thinking how far along in the x value. How far back would we come with the y value? And then how far up or down with the z value? Again, you would put brackets around them and a comma between them. So, to go from the origin up to point C, do we have to go along the x-axis? No, we don't. That would just be daft. Do we have to go back in the y-axis? If we're going from the origin up to here, do we have to come back at all? No, we don't. That would just be daft. So that would also be 0. And finally, how far up do we have to go? So we've not moved along the x-axis. We've not moved back in the y-axis. How far up do we have to go? Brilliant. You've got it. It is 4, which means then the coordinates of point C would be 0, 0, 4. James Bond's friend. Yeah. Example 4, write down the coordinates of point D. Da, 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 da. We can see D is here and it's marked out as being -6. So, once again, think x-axis, y-axis, and z-axis. How far along do we have to go in each of them? And isn't that the dodgiest x in the world? Let's try this. So from the origin, how far along do we have to go in the x-axis to get to this point D? Do we have to go along here? No, we don't. That would just be daft. Do we have to go back in the y-axis either direction? Yeah, brilliant. So because the y-axis goes off in this direction, it means if we go in the opposite direction, well, it's going to be the negative values, which is why it says -6 here. So for the y value, that will be -6. After that, we are at this point, and then do we have to go up or down? No, we don't. That would just be daft. So that just stays as 0. Woo! Which means then D would have the coordinates 0, -6, 0. Write down the coordinates of point E. So once again, we're going from the origin to point E. For this one, once again, you think for the x-axis, what will it be? For the y-axis, what will it be? And for the z-axis, what will it be? Brackets, commas. So, for this one, start at the origin. How far along do we have to go in the x-axis? Yeah, you would come along 8. You can see there's an 8 here, indicating that this length from the origin to this point, when we're changing direction, is going to be 8. So the first value will be 8. After that, for the y value, how far back do we have to go? Yeah, you can see that is 5. Good. So the y value will be 5. And finally, we've come along in the x. We'll come back the way in the y. And going up or down from this point, how far up do we have to go? 2. Good. So that value will just be 2. You got it. Which means the coordinates of point E will be 8, 5, 2. Woo hoo hoo. Example 6, write down the coordinates of point F. So for point F, once again, we're thinking the x value, the y value, and the, you got it, the z value. Brackets, commas. Here we go. So from the origin, how far along would you go in the x-axis? Good, because we're going the opposite direction of the x-axis, we're coming into the negatives. So we're going down to -7. So the x value will be -7. After we've dealt with the x-axis, we think how far back do we go in the y-axis? Well, because we're going in the same direction as the y-axis, we're going to have a positive value of 4. So the y value will be 4. And the z value, how far up or down do we go from here? Good, we're coming up 6. So we'd have -7, 4, and 6. Woo! Example 7, write down the coordinates of point G. Point G is down here, and as it says, be careful with the negatives. I've deliberately missed them out of these numbers, so you need to work out if the numbers are going to be positive or negative. So, from the origin, we need to get from there to this point. So, obviously, we would be coming along here and we're coming down here. That is how we get to that point. So we need to think, first of all, from this point, do we have to go along at all? Do we go along in the x-axis to kind of come along here and then down? Do we go along in x? No! We don't. So the x value will just be 0. For the y value, you can see the y-axis is heading in this direction here. So how far back are we coming? 5. Good. So, need to think, is it going to be positive 5 or negative 5? Just remember, from the origin, the y-axis comes out this way. So that will be 1, and then 2, and then 3, and then 4, and then 5. That's all these different points. But because we're coming in the opposite direction, we're going to have negative 5. What I've done is I've shown you the length from here to here is 5 units, but because we're coming back the way, it will be a negative 5. Good. So it's negative 5 that we would have. Again, I've shown you the distance from here down to here is 9 units. So you need to think, if you write it as a coordinate, would it be positive 9 or negative 9? The z-axis shows the height, and we can see we're coming down 9. The z-axis is going from here and it's going up the way. It's coming up off the page. But if we're heading down the way, instead of a positive value, we will have a negative. So that will be negative 9, meaning G will be going along 0. It'll be coming back 5 in the y, and it'll be going down 9 in the z. So we'd have 0, negative 5, negative 9. Example 8. This is a cube. Each side is 3 centimeters long, and because it's a cube, they're all the same. They are indeed, every single length is 3 centimeters. Write down the coordinates of the 8 vertices, the 8 corners. So, each one we are going from the origin. So, from the origin to get to point A, well, point A is the origin, and because it's the origin, what will the coordinates be? Well, for our x value, y value, and z value, we'd be going along 0 because we're already at that point. We're not coming along. Are we going back the way in the y value? No, we're staying there as well. And are we going up at all? No, we're not. We're just going to stay at 0. So A will be 0, 0, 0, meaning you go along 0, you go back 0, and you go up 0. You just stay there. After that, point B. So how would you get from A to point B? You need to think, how far along do you have to go? How far back do you go? And then how far up do you go? So, how far along do you go? Good, it tells you up here, every side is 3 centimeters long, which means we would come along 3 units. So, the x value will be 3. We're now at this point here. Do we have to go back the way to get to the exact same point that we're sitting on? No, we don't. So that would then be 0. And do you have to then go up the way? Again, no, you don't. So that would also be 0. So we'd have 3, 0, 0. Point C. So we've got the x value, the y value, and the z value. So for the x value, how far along do you have to go from the origin to get to this point? Well, if you think about that, we would come along, then we would go back, and then we would go up. But we were coming along how many units? Yeah, we're coming along 3 units, or 3 centimeters. After that, how far back would you go in the y-axis? Yeah, you can see it's just going to be 3 units. Each side of this cube is 3 centimeters. So we'd go along 3, and then we'd go back 3. So the y value will also be 3. And if we're wanting to get to point C, well, we've already arrived there. So we don't need to be going up or down. So that z value will just be 0. Point D, how would you get to point D? Well, from the origin, how far along do you have to go to get to this point D? Good, you were going along 0. You just want to stay right there. So the x value will be 0. The y value, how far back are you having to go? Yeah, good. For this length here, it's just one of the sides of the cube. So we're coming along 3 units. So that y value will be 3. After that, we're already at that point D. Point D is where we want to get to, so we're not going to be moving up or down. We're just going to be staying exactly where we are. So that will be 0. Point E. How do we get to point E? Well, for this one here, again from the origin, from this point A, think about it, you're wanting to go from there to there. Do we have to go along the way? No, we don't. So that will just be 0. Do we have to go back the way? No, we're not going back the way, so that will also be 0. And are we going up or down? Well, yes, we are. We're going up these 3 centimeters. We're going up 3 units, so that will also be 3. So we'd have 0, 0, 3. Woo! Point F. How do we get to the origin to point F? Well, for point F, again, you want to think how far along would you have to go? How far back would you have to go? And then how far up or down would you have to go? So going along, how far along are we going? Good, it's going to be 3 units because each side of the cube is 3 centimeters. Are we having to go back this way if we want to get to that point here? Well, no, we don't. That would just be daft. We're just wanting to be going straight up. So the y value, because we're not going back, that's just going to be 0. And the z value, because we're going from there up to there, it's along the length of one of the sides, which will be 3. So we'd have 3, 0, 3. And G, going from the origin to point G. So once again, we're wanting to go from there to there. X, Y, and Z, so we have to go along the way, then we've got to go back the way, and then we've got to go up or down the way. So coming along, how far do we go? 3. Good. For the Y value, how far back do you go? 3. Yeah. And for the Z value, how far up or down do you go? 3. You got it. So that's just 3, 3, 3. Well done. And for H, how do you get to point H? Once again, you're going from the origin. You want to think how far along do you go, how far back do you go, and then how far up or down do you go. Let's draw that again. How far up or down do you have to go? So are we coming along this way at all? No, we're not. So that's just going to stay at 0. Then how far back would you have to go? Good, you come back 3 units. And then how far up or down? Good, it's going to be 3 units. Well done. So you'd have 0, 3, 3 for the coordinates for H. Woo! Here's one that's very, very similar. This is a cube, this time with 8 centimeter long sides. Write down the coordinates of each vertex. This is very similar to the last example, so I'll go over this one a little bit quicker, but you may want to test yourself by seeing if you can do this one. So for point A, to go from this point to that point, well, we're already there, so it's going to be 0, 0, 0. For B, because each side is 8 centimeters, it means the length of that would be 8 centimeters, the length of that side is 8 centimeters, length of that side is 8 centimeters. Every single length is going to be 8 centimeters. So to go from A to B, we're coming along 8 centimeters. We're not going back, we're not going up, so we're just going to have 8, 0, 0. For C, to get from A along to here, when you think how far along, how far back, how far up or down. So we're going along 8, good. Going back 8, good. And then going up or down, 0, brilliant. So 8, 8, 0. For D, again, you think how far along do you go, how far back do you go, and how far up or down do you go. So are you coming along to go from A to D? No, you're not. So it starts off with 0. How far back do you go? 8, good. And then how far up or down? Good, that would just be 0 as well, because you're already there at D. For E, again going from A to E, how far along do you go, how far back do you go, how far up do you go? Well, you don't go along, you don't go back, you just go up 8 units. So you don't go along, that's 0, you don't go back, that's 0, and you go up 8. So you'd have 0, 0, 8. For F, to go from A to F, think how far along do you go, how far back do you go, and how far up or down do you go? So we're coming along 8 to get us to B. Then you're not going back at all because we're directly under F, so we just have to go directly up, and we're going up 8 units, so we'd have 8, 0, 8. For G, to get to G, we're coming along 8, we're going back 8, and we're going up 8, so that would be 8, 8, 8. And for H, to go from A to H, think how far along do you go, how far back do you go, and how far up do you go? Well, you're right, you're going along 0. We don't need to move along that way. We just need to go back 8 units to get us to D. And then we have to go directly up 8 units. So we'd have 0, 8, 8. Woo! Example 10, this is a square-based pyramid. Square ABCD has a side length of 10 centimeters. And the height of the pyramid is 13 centimeters. Write down the coordinates of all 5 vertices. So right away we're told this here, ABCD, is a square. and every single side is 10 centimeters. So no, that'll be 10, that'll be 10, this length will be 10, and this length will be 10 as well. And the height of the pyramid, so from the top down to the bottom, bump, will be 13 centimeters. Let's squeeze a little 13 just in there. So, write down the coordinates of all 5 vertices. For point A, we are going to be starting at this origin where the x, the y, and the z axes cross. So we want to get to point A. We're already at point A, so we go along 0, we go back 0, and you go up 0. Good. For point B, going from the origin, this point A, how far along do you go? 10. Good, you're going along 10. How far back would you then go to get to point B, which is what you're at? Yeah, you wouldn't go along at all. That would just be 0. And how far up or down would you go? 0. Good, you would just stay there. We're going along 10. We're not going back. We're not going up. That takes us just to that point B. For C, think how far along do you go? How far back do you go? And how far up or down do you go? Good, you'd be going along 10. Brilliant. That would take us to B. Then how far back do you go in the y-axis? Good, we'd be going back 10 units. Brilliant. And if we're at C then, we don't need to go up or down, we just need to stay there. So that would be 10, 10, 0. With D, again, think X, Y, and Z. So how far along do you have to go to get from A to D? Well, if you go along, it doesn't help us at all. So we don't go along, we just stay there. How far back do you go? Well, yeah, you're just going to cross to the other side of that pyramid. And that would be a length of 10 units. And once you've done that, we're already at D, so we do not have to go up. So that would just be 0, 10, 0. And finally, for E, tricky one, this one, we want to get to this point here. Well, because it's a pyramid, this point E is directly above the center of this square here. So that there is going to be the center. So if you put in the diagonals, that there is going to come down bang in the middle. So because of that, if you think how far along do you go, how far back do you go, and how far up or down do you go, well, what you have to do is you, instead of going from A back to B, you just go halfway. You would just go to that point. So you would only go along how many units? 5. Good. So you come along 5 units. Once you've done that, you're then in the center of this line. So we're then traveling back here. But you don't go right the way across to the other side. What you do is you just go halfway. So instead of coming along all 10 units, we just go along 5. That takes us bang to the center of that square. And once you've done that, because you're bang in the middle of it, how far up would you have to go then to get up to E? Yeah, you can up 13. That is a height of 13 units. So you'd have 5, 5, 13. Woo! In example 11, final example. This once again is a square-based pyramid. Square ABCD has a side length of 8 centimeters. So the sides of it, that would be 8 centimeters. That there would be 8 centimeters. That there is going to be 8 centimeters. That there's 8 centimeters and 8 centimeters. And it's got a height of 9 centimeters. So from the top down to the middle of this square is going to be 9 centimeters. So, points A, B, C, D. Well, you can see here point A is not at that origin. What you've done for point A is we've moved it. So we need to think once again, think what the X value would be, think what the Y value would be, and think what the Z value would be. Brackets, commas. So for the X value, to go from the origin to A, you can see we're coming along a length of 3 units. Even though this 3 is just floating about in the middle of the line, I'm indicating that this length here, before you change direction, is just 3 units long. So we're coming along 3. Then how far back are you going? Well, from here, in the y-axis, you're coming back 2 units. So we're going to have a 2. And then from this point, you're just going up directly 1 unit. So you'd have 3, 2, 1. Woo! After that, you've got B. How do you work out what B would be? Well, once again, you're thinking, what's the X value? What's the Y value? What's the Z value? But this time, instead of just stopping here at the 3, we want to keep going along. We're coming along the length of this line. And this line is 8 units long, or 8 centimeters long. So we're coming back 3, but then we're going along another 8. And that'll take us how far we need to go along. So 3 plus 8 means we would have an X value of 11. After that, we're coming back the way, and then we're going to have to go up. But really, that distance there is the exact same as to get to point A. We're going to have to go in 2 units, and then up 1 unit. So we would have 2 units there for the y value, and then after that, we're going directly up 1 unit. So you'd have 11, 2, 1. For C, to get to point C, well, you're kind of doing the same thing as B. We're going along 11 units. First of all, that'll take us to the other end of that pyramid. So we're coming along the 11 units. After that, we're going to have to go back in the y-axis, but instead of stopping at the 2 and then going up the way, we want to keep on going. And we want to keep on going these other 8 units. So we were going in 2 to get to the start of the pyramid. The length of the line is 8, so 2 add 8 gives us 10. And once you've done that, you're directly underneath C, and to go from C, to go from that point to C, you just go up 1 unit. So you'd have 11, 10, 1. With D, how do you get to point D? Well, that's on the same side of it as point A. So we're coming along these 3 units. That'll take us to this edge of the pyramid. So the first value will be 3. After that, same thing again. If you go 2 units, you get to the front of this pyramid. But you want to keep going right the way along. And you want to go along to the other side of the pyramid. The pyramid is 8 centimeters long. So you go in 2 to get to the start of it. If you keep going to 8, it'll take you just to this edge of the pyramid. So 2 add 8 gives us 10. And once you've done that, you're directly underneath D. So you just want to go up the way. And again, because it's 1 centimeter off the ground, it would be 3, 10, 1. And for E, E is going to be the tricky one. Because what we're having to do with this is we have to find the center of this square first of all. So to do that, we know this length is 8, and half of that length will just be 4. And then we're going right the way across here, but not to the other side. We're just going to cross to the center. So that will also be a length of 4 because it's half of that length. So thinking about it with the x value, y value, and z value, we're coming along 3 units to get to the start of that pyramid, but then you've got to go back another 4. So 3 add on the 4 gives us 7. Once we've done that, we're having to go from this in 2 units to get to the start of this pyramid, but we're then going along another 4. So 2 add the 4 gives us 6. And once we've done that, if we know we go up 1 centimeter, it takes us to the bottom of the pyramid, but the pyramid is 9 centimeters tall, so it's the 1 centimeter to get to the bottom of it, plus the 9, which is the height, which gives us 10 centimeters. So what we've got is that being 7, 6, 10 for point E. That is as tricky as you would ever get it. Once you feel confident with these questions, maybe go back, look at another few on your own if you don't, but try some of these questions. The best resource I could find is the Zeta Maths website. Have a look at their National 5 book from page 241 to 243, exercise 23.5. There are loads of questions on this, and it goes from easy through to hard. Best of luck! Woo!
Good luck, National 5.